What is firewall? In this video, we are going to see about what is firewall. A computer network is a collection of autonomous computing devices sharing data communications technology that enables them to exchange information. An internetwork is a set of individual networks interconnected by the appropriate devices in such a way that they can behave as a single larger network. These definitions are built around the ideas of providing connectivity and making information exchange possible, two goals achieved with undoubted success. Internetworking has definitely changed the way people live, learn, play, and work. This is poetic and appealing, but it is always important to remember that Internet also brings to the scene dangerous features such as anonymity, the ability to remotely control computers, and automated task execution. There should be some means to compensate for the absence of natural boundaries in the Internet. With the realm of computer networks, a firewall is a security system that lends itself to the task of isolating areas of the network and delimiting domains of trust. Building upon this initial state of isolation created by the firewall, access control policies that specify the traffic types entitled to go from one domain to another can be defined. The firewall acts as a sort of conditional gateway. The criteria to permit traffic normally defined in the firewall policy and ideally should relate to what is stated in the security policy of the organization. Firewall characteristics. In this animation, we are going to learn about firewall characteristics. Goals for firewall. All traffic from inside to outside and vice versa must pass through the firewall. This is achieved by physically blocking all access to the local network except via the firewall. Only authorized traffic as defined by the local security policy will be allowed to pass. Various types of firewalls are used, which implement various types of security policies. The firewall itself is immune to penetration. This implies the use of a hardened system with a secured operating system. Trusted computer systems are suitable for hosting a firewall and often required in government applications. Firewall techniques. The following shows a list of 4 general techniques that firewalls use to control access and enforce the site's security policy. Service control, direction control, user control, behavior control. Service control. Service control determines the types of internet services that can be accessed inbound or outbound. The firewall may filter traffic on the basis of IP address, protocol, or port number, may provide proxy software that receives and interprets each service request before passing it on, or may host the service software itself, such as a web or mail service. Direction control. Direction control determines the direction in which particular service request may be initiated and allowed to flow through the firewall. User control controls access to a service according to which user is attempting to access it. This feature is typically applied to users inside the firewall perimeter, that is, local users. It may also be applied to incoming traffic from external users. The latter requires some form of secure authentication technology, such as provided in IPsec. Behavior control controls how particular services are used. For example, the firewall may filter email to eliminate spam, or it may enable external access to only a portion of the information on a local web server. Scope of a firewall. A firewall defines a single choke point that keeps unauthorized users out of the protected network, prohibits potentially vulnerable services from entering or leaving the network, and provides protection from various kinds of IP spoofing and routing attacks. The use of a single choke point simplifies security management because security capabilities are consolidated on a single system or set of systems. A firewall provides a location for monitoring security-related events. Audits and alarms can be implemented on the firewall system. A firewall is a convenient platform for several internet functions that are not security related. These include a network address translator, which maps local addresses to internet addresses, and a network management function that audits or logs internet usage. Security Gateway. The security engine that enforces the organization's security policy and acts as a security enforcement point. The security gateway is managed by the security management server and sits on the network as an entry point to the LAN. Security management server. The server used by the system administrator to manage the security policy. The organization's databases and security policies are stored in the security management server and downloaded to the security gateway. Smart Dashboard. A smart console GUI application that is used by the system administrator to create and manage the security policy. Limitations of firewall. The firewall cannot protect against attacks that bypass the firewall. Internal systems may have dial-out capability to connect to an ISP. An internal LAN may support a modem pool that provides dial-in capability for traveling employees and telecommuters. The firewall may not protect fully against internal threats such as a disgruntled employee or an employee who unwillingly cooperates with an external attacker. An improperly secured wireless LAN may be accessed from outside the organization. An internal firewall that separates portions of an enterprise network cannot guard against wireless communications between local systems on different sides of an internal firewall. A laptop, PDA, or portable storage device may be used and infected outside the corporate network and then attached and used internally. Types of firewall. Now we are going to see about the types of firewall. A firewall may act as a packet filter. It can operate as a positive filter, allowing to pass only packets that meet specific criteria, or as a negative filter, rejecting any packet that meets certain criteria. Depending on the type of firewall, it may examine one or more protocol headers in each packet, the payload of each packet, or the pattern generated by the sequence of packets. The major advancements in firewall technologies as follows. Packet filtering firewall, stateful inspection firewall, application level gateway, circuit level gateway. Packet filtering firewall. In this animation, we are going to learn about packet filtering firewall. Packet filtering firewall. A packet filtering firewall applies a set of rules to each incoming and outgoing IP packet and then forwards or discards a packet. The firewall is typically configured to filter packets going in both directions from and to the internal network. Filtering rules are based on information contained in a network packet. Source IP address, destination IP address, source and destination transport level address, IP protocol field. Interface. Source IP address, IP address of a system that generated IP packet, for example 192.178.1.1. Destination IP address, the IP address of the system the IP packet is trying to reach, that is, for example 192.168.1.2. Source and destination transport level address, the transport level, for example TCP or UDP port number, which defines applications such as SNMP or Telnet. IP protocol field defines the transport protocol. Interface. Interface. For a firewall with 3 or more ports, which is the interface of the firewall the packet came from, or which interface of the firewall the packet is destined. The packet filter is typically set up as a list of rules based on matches to fields in the IP or TCP header. If there is a match to one of the rules, that rule is invoked to determine whether to forward or discard the packet. If there is no match to any rule, then a default action is taken. Two default policies are possible. Default is equal to discard, that which is not explicitly permitted is prohibited. Default is equal to forward, that which is not explicitly prohibited is permitted. Default discard. The default discard policy is more conservative. Initially, everything is blocked and services must be added on a case-by-case basis. However, this is the policy likely to be preferred by businesses and government organizations. Further visibility to users diminishes as rules are created. Default forward. The default forward policy increases ease of use for end users but provides reduced security. The security administrator must, in essence, react to each new security threat as it becomes known. This policy may be used by generally more open organizations such as universities. In each set, the rules are applied top to bottom. The asterisk in a field is a wildcard designator that matches everything. Assuming that the default is equal to discard policy is in force, rule set A. Inbound mail is allowed, that is port number 25 is for SMTP's Simple Mail Transfer Protocol incoming, but only to a gateway host. However, packets from a particular external host, SpyGod, are blocked because that host has a history of sending massive files in email messages. Rule set B. This is an explicit statement of the default policy. All rule sets include this rule implicitly as the last rule. Rule set C. This rule set is intended to specify that any inside host can send mail to the outside. A TCP packet with the destination port of 25 is routed to the SMTP server on the destination machine. The problem with this rule is that the use of port 25 for SMTP received is only a default. An outside machine could be configured to have some other application linked to port 25. As this rule is written, an attacker could gain access to internal machines by sending packets with a TCP source port number of 25. Rule set D. This rule set achieves the intended result that was not achieved in C. The rule takes advantage of a feature of TCP connections. Once a connection is set up, the ACK flag of a TCP segment is set to acknowledge segments sent from the other side. Thus, this rule set states that it allows IP packets where the source IP address is one of a list of designated internal hosts and the destination TCP port number is 25. It allows incoming packets with a source port number of 25 that include the ACK flag in the TCP segment. Note that user explicitly designates source and destination systems to define these rules explicitly. Rule set E. This rule set is one approach to handling FTP connections. With FTP, two TCP connections are used: a control connection to set up the file transfer and a data connection for the actual file transfer. The data connection uses a different port number that is dynamically assigned for the transfer. Most servers and hence most attack targets use low-numbered port. Most outgoing calls tend to use a higher numbered port, typically about 1024. Thus, this rule set allows packets that originate internally, reply packets to a connection initiated by an internal machine, packets destined for a high-numbered port on an internal machine. This scheme requires that the system be configured so that only the appropriate port numbers are in use. Rule set E points out the difficulty in dealing with applications at the packet filtering level. Another way to deal with FTP and similar applications is either stateful packet filters or an application level gateway. One advantage of a packet filtering firewall is its simplicity. Also, packet filters typically are transparent to users and are very fast. Weakness of packet filtering firewall. Packet filter firewalls do not examine upper layer data. They cannot prevent attacks that employ application-specific vulnerabilities or functions. Another weakness is the limited information available to the firewall. The logging functionality present in packet filter firewalls is limited. Most packet filter firewalls do not support advanced user authentication schemes. Packet filter firewalls are generally vulnerable to attacks and exploits that take advantage of problems within the TCP/IP specification and protocol stack, such as network layer address spoofing. Spoofing attacks are generally employed by intruders to bypass the security controls implemented in a firewall platform. Finally, due to the small number of variables used in access control decisions, packet filter firewalls are susceptible to security breaches caused by improper configurations. Stateful inspection firewall. In this video, let us see the application of stateful inspection firewall. Stateful inspection firewall. A traditional packet filter makes filtering decisions on an individual packet basis and does not take into consideration of any higher layer context. Most standardized applications that run on top of TCP follow a client-server model. For example, for SMTP, email is transmitted from a client system to a server system. The client system generates new email messages, typically from user input. The server system accepts incoming email messages and places them in the appropriate user mailboxes. SMTP operates by setting up a TCP connection between client and server, in which the TCP server port number, which identifies the SMTP server application, is 25. The TCP port number for the SMTP client is a number between 1024 and 65,535 that is generated by the SMTP client. In general, when an application that uses TCP creates a session with a remote host, it creates a TCP connection in which the TCP port number for the remote, that is server application, is a number less than 1024, and the TCP port number for the local, that is client application, is a number between 1024 and 65535. The numbers less than 1024 are the well-known port numbers and are assigned permanently to particular applications, for example 25 for server SMTP. The numbers between 1024 and 65535 are generated dynamically and have temporary significance only for the lifetime of a TCP connection. A simple packet filtering firewall must permit inbound network traffic on all these high-numbered ports for TCP-based traffic to occur. This creates a vulnerability that can be exploited by unauthorized users. A stateful inspection packet firewall tightens up the rules for the TCP traffic by creating a directory of outbound TCP connections as shown in the table below. There is an entry for each currently established connection. The packet filter will now allow incoming traffic to high-numbered ports only for those packets that fit the profile of one of the entries in this directory. A stateful packet inspection firewall reviews the same packet information as a packet filtering firewall, but also records information about TCP connections. Some stateful firewalls also keep track of TCP sequence numbers to prevent attacks that depend on the sequence numbers, such as session hijacking. Some even inspect limited amounts of application data for some well-known protocols like FTP, IM, that is instant messaging, and SIPs, that is session initiation protocols commands, in order to identify and track related connections. Application level gateway. Now we are going to see about what is application level gateway. Application level gateway. An application level gateway, also called an application proxy, acts as a relay of application level traffic. The user contacts the gateway using a TCP/IP application such as Telnet or FTP, and the gateway asks the user for the name of the remote host to be accessed. When the user responds and provides a valid user ID and authentication information, the gateway contacts the application on the remote host and relays TCP segments containing the application data between the two endpoints. If the gateway does not implement the proxy code for a specific application, the service is not supported and cannot be forwarded across the firewall. Further, the gateway can be configured to support only specific features of an application that the network administrator considers acceptable while denying all other features. Advantages of application level gateway. Application level gateways tend to be more secure than packet filters. Rather than trying to deal with the numerous possible combinations that are to be allowed and forbidden at the TCP and IP level, the application level gateway need only to scrutinize a few allowable applications. In addition, it is easy to log and audit all incoming traffic at the application level. Disadvantages of application level gateway. A prime disadvantage of this type of gateway is the additional processing overhead on each connection. In effect, there are two spliced connections between the end users with the gateway at the splice point, and the gateway must examine and forward all traffic in both directions. Circuit level gateway. From the animation, let us see about circuit level gateway. A fourth type of firewall is the circuit level gateway or circuit level proxy. This can be a standalone system, or it can be a specialized function performed by an application-level gateway for certain applications. As with an application gateway, a circuit-level gateway does not permit an end-to-end TCP connection. Rather, the gateway sets up two TCP connections, one between itself and a TCP user on an inner host, one between itself and a TCP user on an outer host. Once the two connections are established, the gateway typically relays TCP segments from one connection to the other without examining the contents. The security function consists of determining which connections will be allowed. A typical use of circuit-level gateways is a situation in which the system administrator trusts the internal users. The gateway can be configured to support application-level or proxy servers on inbound connections and circuit-level functions for outbound connections. In this configuration, the gateway can incur the processing overhead of examining incoming application data for forbidden functions, but does not incur that overhead on outgoing data. The gateway can be configured to support application-level or proxy servers on inbound connections and circuit-level functions for outbound connections. The package version 5 of SOCKS is specified in RFC 1928. The RFC defines the SOCKS as follows. The protocol described here is designed to provide a framework for client-server applications in both TCP and UDP domains to conveniently and securely use the services of a network firewall. The protocol is conceptually a shim layer between the application layer and the transport layer, and as such does not provide network layer gateway services such as forwarding of ICMP messages. SOCKS consists of the following components. The SOCKS server, which often runs on a Unix-based firewall. SOCKS are also implemented on Windows systems. The SOCKS client library, which runs on internal hosts protected by the firewall. When a TCP-based client wishes to establish a connection to an object that is reachable only via a firewall, it must open a TCP connection to the appropriate SOCKS port on the SOCKS server system. The SOCKS service is located on TCP port 1080. If the connection request succeeds, the client enters a negotiation for an authentication method to be used, authenticates with the chosen method, and then sends a relay request. The SOCKS server evaluates the request and either establishes the appropriate connection or denies it. Bastion host. In this video, we are going to learn about Bastion host. This is common to a base firewall on a standalone machine running a common operating system such as Unix or Linux. Firewall functionality can also be implemented as a software module in a router or LAN switch. A Bastion host is a system identified by the firewall administrator as a critical strong point in the network security. Typically, the Bastion host serves as a platform for an application level or circuit level gateway. Common characteristics of a Bastion host are as follows. The Bastion host hardware platform executes a secure version of its operating system, making it a hardened system. Only the services that the network administrator considers essential are installed on the Bastion host. These could include proxy applications for DNS, FTP, HTTP, and SMTP. The bastion host may require additional authentication before the user is allowed access to the proxy services. In addition, each proxy service may require its own authentication before granting user access. Each proxy is configured to support only a subset of standard applications command set. Each proxy is configured to allow access only to specific host systems. This means that the limited command or feature set may be applied only to a subset of systems on the protected network. Each proxy maintains detailed audit information by logging all traffic, each connection and the duration of each connection. The audit log is an essential tool for discovering and terminating intruder attacks. Each proxy module is a very small software package specifically designed for network security. Because of its relative simplicity, it is easier to check such modules for security flaws. For example, a typical Unix mail application may contain over 20,000 lines of code, while a mail proxy may contain fewer than 1,000. Each proxy is independent of other proxies on the bastion host. A proxy generally performs no disk access other than to read its initial configuration file. Hence, the portions of the file system containing executable code can be made read-only. This makes it difficult for an intruder to install Trojan horse sniffers or other dangerous files on the bastion host. Each proxy runs as a non-privileged user in a private and secured directory on the bastion host. Firewall configuration and screen host firewall system. In this video, we are going to see about firewall configuration and screen host firewall system. Firewall configuration. A firewall is positioned to provide a protective barrier between an external, potentially untrusted source of traffic and an internal network. With that general principle in mind, a security administrator must decide on the location and on the number of firewalls needed. Some common options are screen host firewall system, screened subnet firewall system, screen host firewall system. The configuration of the screened host firewall uses dual-homed bastion host, adds significantly to security compared to a single-homed bastion host. This firewall implementation is secure due to the fact that it creates a complete break between the internal network and the external internet. As with a single-homed bastion, all external traffic is forwarded directly to the bastion host for processing. However, a hacker may try to subvert the bastion host and the router to bypass the firewall mechanisms. Even if a hacker could defeat either the screening router or the dual-homed bastion host, the hacker would still have to penetrate the other. Nevertheless, a dual-homed bastion host removes even this possibility. It is also possible to implement NAT, Network Address Translation, for dual-homed bastion hosts. Screen subnet firewall system. Now let us see the process of screen subnet firewall system. The screen subnet firewall, which is also known as DMZ, that is demilitarized zone. This firewall is the most secure and simple because it uses a bastion host to support both circuit and application level gateways. As shown in figure, all publicly accessible devices including modem and server are placed inside the DMZ. This DMZ then functions as a small isolated network positioned between the internet and the internal network. The screened subnet firewall contains external and internal screening routers. Each is configured such that its traffic flows only to or from the Bastion host. This arrangement prevents any traffic from directly traversing the DMZ subnetwork. External screening router. The external screening router uses standard filtering to restrict external access to the Bastion host and rejects any traffic that does not come from the Bastion host. This router also uses filter to prevent attacks such as IP spoofing and source routing. Internal screening router. The internal screening router also uses rules to prevent spoofing and source routing. Like its external counterpart, this internal router rejects incoming packets that do not originate from the Bastion host and sends only outgoing packets to the Bastion host. Benefits of the screened subnet firewall. A hacker must subvert 3 separated tri-homed interfaces when user wants to access the internal network, but it is almost infeasible. The internal network is efficiently invisible to the internet because all inbound or outbound packets go directly through the DMZ. This arrangement makes it impossible for a hacker to gain information about the internal systems because only the DMZ is advertised in the routing tables and other internet information. Third, internal users cannot access the internet without going through the Bastion host because the routing information is contained within the network.